Hello everybody, this is a video about like terms and the distributive property. I am your host Mr. Shirley, the rootinest tootinest math teacher in southwestern Ontario. Please make a brief note as we go through this video, put a date and a title on there, and our learning goal, which again you don't need to write down, is to consider methods for simplifying algebraic expressions, which sounds fancy but it's really not that tricky. Just reminding you again that this is a video. Feel free to pause or to replay it if you just can't get enough of my voice. Alright, so like terms are terms that have the same variable portion. Okay, so these are some examples of like terms. Alright, so 5a, 3a, negative 2a. These are like terms because they all just have a single a as the variable portion of each term. Okay? Hopefully that makes sense. 4, 15, negative 3, 10 are also like terms. They simply don't have a variable portion, but they all don't have one, so they are like terms. All right, 4a, 3n, 2, 6z squared, these are unlike terms because they have different letters, different variable portions. 2 doesn't have one at all, but you get the idea. Okay, these are unlike terms because all of the variable portions are different. And the last one, 5n, 3n squared, 7n cubed, these are also unlike terms because of those exponents. Okay, so because the exponents are different on those, so we've got a 2 and exponent 3, that means they're unlike. Even though they all have an n, the exponent means they are not like terms anymore. They must all have the same exponent, which in the case of our first example up there is none. It is possible for them to have an exponent. So for example, if they were all had an n squared on them, if we had 2n squared, 3n squared, and so on, those are like terms. Okay, because they have the same variable portion, meaning variable and exponent. Okay, so those are also like terms. Now, like terms can be added or subtracted to simplify them. Okay, so it's also called collecting like terms, depending on the terminology that you would like to use. So 5n plus 3n would equal 8n. Okay, hopefully that's fairly logical. You basically just add up the coefficient in front. Okay, so you're adding up the number. All right, it's very simple math. Now, when you get to our second example here, so 5a plus 3 minus 2a plus 1, just remember that you can only add together the like terms or subtract the like terms. So we cannot add the 5a and the 3. Can't do it unless you know what a is, which in this case isn't really what we're concerned about. Okay, so what you're wanting to do with this one, my suggestion is you basically cover over the 3 in the middle, consider 5a minus 2a. All right, and that gets you 3a. Okay, 5 minus 2 gets us 3a, and then 3 and 1, which are the other pair of like terms, adds up to 4. Okay, so I'm just going to use some different pen colors here just to emphasize that. So 5a and 2a are like terms. Sorry, I should say they're negative 2a or subtracting 2a. There are two like terms, and then 3 and 1 are also like terms. So we compare those in our answer. All right, so hopefully that's fairly straightforward. Just only add or subtract the like terms. All right, the last one here, 5x plus 2y equals, well, nothing. It's already in simplified form. Okay, the x and the y are not like terms, so there's really nothing you can do with it. One thing to keep in mind is that you can multiply and divide unlike terms. Okay, so you can multiply and divide them all you want, but for adding and subtracting, which we will commonly use to simplify them, you can only do it with like terms. All right, on we go. Please pause the video for a moment and try out these questions. Okay, so for our example in A, so 5x and 3x are like terms, so that's 8x, 5 plus 3. And the a terms there, 2 and 7, or negative 2 and 7, if we take negative 2 plus 7, we end up with 5a. All right, And that's our answer. Again, we can't simplify it because the x and the a are different. Can't simplify it anymore, rather. Okay, and our last one here has things in a slightly different order and three different kind of pairs of like terms. So our first one, so 6 plus 3 means we have 3. Mr. Shirley, that is some shoddy math. We have 9. 6 plus 3 is 9. Okay. All right. On we go. Hopefully the rest of this is correct, but it'll be a bit of a mystery. So negative 2a minus 8a means minus 10a. Hey, 3 cheers for Mr. Shirley. We got that one. And then the last one, positive b plus 2b. Okay. So 9 minus 10a plus 2b. And then since these are all unlike terms now, we can't simplify that anymore. On we go. So the distributive property, which you may have seen before, must be used when expanding the bracket part of an expression. Okay, so this can be used within order of operations, or it can be kind of just on its own, like these two questions right here. Okay, and basically what you do when you tackle the distributive property is you take the number in front and you multiply it by each of the things in it. Okay, so you multiply 5 times a, and then you multiply 5 times 3. And you would just keep whatever sign that is right in there as you're going through. Okay? Why can I not move that? So 5 times a plus 5 times 3, which leaves us with 5a plus 15. Okay? And remember, we leave it as 5a because that's often how we write it. It would be a little bit annoying to write that multiplication sign every time. So we just put 5a plus 15. Okay? Second example here, so 2 times 3n. Now when you're multiplying numbers like this, okay, we've got one with a variable, one without, all you do is you multiply the coefficients in front. Okay, so 6, and then you keep the n because the n is there, it can't just disappear, but there's nothing else that we're really multiplying with, and we don't know what it is because that's not really the point of the question, so we leave it there. But you just multiply the coefficients, so 2 times 3 equals 6. And then plus 14 because that was 2 times 7. Okay? One way to kind of remember this is that you're distributing the multiplication to each term in the brackets. Okay, so take a moment, pause the video, and try out these 3 questions right here. I'll assume you did that. So for this one here, remember we're doing negative 4 times 5, negative 4 times x, and negative 4 times negative 2y. Okay, so negative 4 times 5 is negative 20. Subtract 4x, so that's 4 times x. Okay, and sometimes that can be a little confusing for students when you're multiplying a number times only a variable, but remember that it is as though there's a 1 in front of it. Okay, because really there is, we just don't typically write it. So there's a 1 right there. It's really 1x. So we're doing negative 4 times 1 and then x. Okay, and just keep that sign for it. So negative 4 times positive 1 would end up being negative 4. So subtract 4x. And then the negative 4 times negative 2 would become positive 8 if you remember your integer rules, and then the y just sticks around. Okay, on we go. So 7 times negative 2a, so we've got negative 14a minus 21b plus 28c. Okay, one thing to keep in mind when you're doing questions like this, I've made the examples so this doesn't happen, but it sometimes will in examples. Sometimes you can simplify what is inside the brackets first, like you would do with proper order of operations. So do that first, it makes your multiplication easier. Okay, but once you've already simplified it, there's not anything else you can do except do the multiplication portion of it. Okay, unless someone tells you in the question what a, b, and c are equal to, there's nothing else you can do. Okay, so this one, the last one here, so you would do negative 5 times a, so negative 5a plus 15 plus 8a plus 10. So again, 2 times 4, 2 times 5 to get 8 and 10, negative 5 times the 1a there, negative 5 times negative 3. But then you can simplify this one a little bit more, if you remember what we did at the start earlier on in the slideshow. So negative 5a plus 8a equals 3a, and then 15 plus 10 equals 25. So try out some of those, get a little bit of practice with those. You will need to do this a bunch in future years. So please try to be as comfortable with it as you can, but ask me any questions as you're going through the work. Let me know if you're having any issues with it, and I would be happy to help in any way I can. So I thank you for watching this video. Have a super duper day.